Hey there, we are going to look at basic subtraction in this video and some different components that go with basic subtraction along with some properties. So to start, I want to just mention that subtraction is often used alongside addition or mentioned alongside addition, but oftentimes there are more mistakes that come with subtraction as opposed to addition. So it can often lead to more loss of points if it's not handled correctly. So we are going to talk about subtraction of negative numbers to start. And we're going to start with the expression a minus negative b. So a minus negative b right here. In this case, you are required to subtract negative b from positive a. So we see that double subtraction or that double negative. So a subtraction sign and then a negative number after it. So subtracting a negative number is equivalent to adding the same number in its positive form. So for example, a minus negative b is really the same as a plus b. So that double negative really turns into a plus between. So 3 minus negative 2 is really the same as 3 plus positive 2. 3 plus positive 2 is 5. On number 2, we see 11 minus negative 9. This is really 11 plus 9, which is 20. And then finally, 108 minus negative 97. This is really 108 plus positive 97. Now, this one may not be as simple to do in your head as these two. So let's use some of our tricks that we've learned in a previous video as to how to add numbers in a quicker way. So looking at this 97, the way that I think of this is, okay, 97 is really 100 minus 3. So if I can add 100, but then subtract 3, that will be the same as adding 97. So I'm going to take 108, I'm going to add 100 to it, and when I do that, 108 plus 100 is 208, but I added an extra 3 when I added 100 instead of 97, so then I need to subtract 3 still, and that's how I get 205. So now we are going to look at commutative and associative properties for subtraction. Unfortunately, there actually is no commutative or associative property that works for subtraction like there was for addition. And that's because the order of operations requires you to solve subtraction expressions from left to right to get the correct value. So if I had a problem like 3 minus 2 or 6 minus 3 minus 1, both of those I need to solve from left to right in order. Otherwise, I do not get the right answer. So the commutative and associative properties of addition are great tools, but they cannot be applied to subtraction directly unless you transform the subtraction to addition, which we're going to look at here in a second. So I just want to point out 3 minus 2 is 1. But I can't just switch the 3 and the 2 to get 2 minus 3 and get the same answer. 2 minus 3 will be negative 1. Negative 1 and 1 are not the same answer. And so that shows me that unfortunately I cannot use the commutative property because I can't just switch it with subtraction. Okay, so now let's go ahead and look at 6 minus 3 minus 1. So 6 minus 3 right here, 6 minus 3 gives us 3. And then when we do 3 minus 1 in order, we get 2. So 2 is the correct answer. In this case, if I had started with the 3 minus 1 instead, 3 minus 1 right here gives me 2. And if I do 6 minus 2, I get 4. That is not the correct answer. It does not match the 2 that we got over here. So if you are going to leave it as subtraction, you have to do the first 2, and then the next one we would subtract, and then if there were more, you would subtract in order from left to right. So the transformation of an expression which includes subtraction to an expression in which you can apply the commutative and associative properties of addition relies on carrying the plus or minus sign as the coefficient of the number, meaning the sign goes with the number, not just the number itself moving without the sign. This is equivalent to adding plus signs before any terms of the expression. So let me show you what we mean by that. So the commutative property workaround for subtraction. So this is considered a workaround because it is not actually possible to use a commutative property for subtraction in the way that you would addition. But we can transform that subtraction into addition using a negative sign as the coefficient. So it moves with the number. Then we are able to use the commutative property to switch the order. So for example, 3 minus 2. I can rewrite this as 3 plus negative 2. 3 plus negative 2 is the exact same thing as 3 minus 2. Usually we leave it as 3 minus 2, but if I wanted to switch the order, and this is really just helpful in some scenarios, in this case specifically, 3 minus 2, we would just probably do 3 minus 2 and get 1. But sometimes it's helpful to be able to switch it around the other way. And so here, 3 plus negative 2, we can now apply the commutative property because it is addition right here between the two numbers 3 and negative 2. Because it is addition, we can go ahead and apply the commutative property of addition. So that means we can switch the order of 3 and negative 2, and we now have negative 2 plus 3. Negative 2 plus 3 is 1. Again, that is the same as what we get if we just originally did 3 minus 2, which is 1. So the commutative property works if we pull that sign with the number when we move around the order of the numbers. Okay, and then we have the associative property workaround. So again, it is a workaround because there is not actually an associative property of subtraction. Instead, we want to go ahead and, again, just like we did on the last one, take those negative signs and really attach them to the number. And then the number moves with the negative sign, not just the number alone. So we have 6 minus 3 minus 1. And remember, if we do 6 minus 3 minus 1 in order from left to right without changing the order of the numbers or the grouping of the numbers, 6 minus 3 is going to be 3. And then we subtract 1. 3 minus 1 is 2. So if we do this correctly, we will get 2 as our answer. So looking at this, we rewrite the 6 as 6 plus negative 3 plus negative 1. So you see that the negative sign goes with, or the subtraction sign goes with the 3 and with the 1. And so that's where we get plus negative 3 and plus negative 1. Again, now we have it written as addition, so we can use the associative property of addition. And remember, the associative property of addition allows us to group different numbers first, or in other words, add different numbers together first instead of what numbers come first in the expression. So we don't have to do 6 plus negative 3 first. Now that we have it written as addition, we can group it. For example, we see these sets of parentheses here. Negative 3 plus negative 1. They want us to do that first, or they're showing how you could do that first. Negative 3 plus negative 1. When we do that part alone, we get negative 4. And then now we have 6 plus negative 4. 6 plus negative 4 is the same as 6 minus 4. And 6 minus 4 is 2. So it does still work out. It matches how we do it without changing around the order or the grouping. But this is just to show you that you can change it around if you turn the subtraction into plus a negative number instead. So we talked about how there is actually no commutative or associative property for subtraction. However, we do have some workarounds. So if we change subtraction into addition of a negative number, then we can go ahead and use the commutative property and associative property of addition because we've now changed it into addition. So just like we looked at up above, we have 3 minus 2, we changed it into addition, we swapped the order, and we still got the same answer to show that the commutative property of addition can be applied if we change that subtraction into plus a negative number. So with the associative example, again, we can change the 6 minus 3 minus 1 into addition. So 6 plus negative 3 plus negative 1, so that we can group together different orders of numbers. So for example, we can do negative 3 plus negative 1 first, and then we were able to use that associative property by grouping those together and then simplifying from there. So 6 plus negative 4 turned into 6 minus 4, which was 2. Now, again, sometimes this may not be beneficial, but sometimes it is helpful to know that information or be able to use that on problems where it might be easier to change the order or change the grouping of which numbers you add or subtract together first. So hopefully this helps a little bit, again, with our subtraction of negative numbers and our workarounds for our commutative and associative properties of subtraction.